Hi, everyone. The other day, I was asked a very specific question to talk more about fractions and decimals and mixed numbers and how do you convert in and out. So I am going to try to throw something together right here, right now, so that you can know how to do it. Okay, so it's so simple. I just have a single one of these because I don't want to get up and stand. I'm just going to show you. Hopefully the glare won't be too bad. And then as I erase, I will write it down here so I don't lose track. But I will hope that you follow along and for your own self. And if you lose track of something, go ahead and watch it again. Okay, so let's pick a number, any number. Let's just, because this popped into my mind, let's go with 2.65. Okay? Now, you gotta say, oh, that's $2.65. Can you read that? Now, I just want to show you how numbers go together, okay? And how you can convert them. This is in decimal form. It's a decimal, okay? But it has a whole number part. If you remember, these are called the ones. If you get further over here, it's called the tens, but we don't have any tens. Hundreds, right? These are called the tenths. These are the hundredths. The hundredths are the cents, C-E-N-T-S, which is short for century, centurion. Cent is 100. So it's the 100th part. That's why we say like $2.65. People understand the decimal system because of commerce, but they don't understand other systems necessarily. So I'm going to show you how to convert this. Okay? You can convert any number this way. First of all, you literally you take however many these are and you put it over zeros and a 1. So the 2 is already a whole part. So we're going to say 2, stays 2. And 65 100ths. Literally, like I write the zeros first and then I put the 100 down. Because it just helps remind you how many places you need. Okay. This is now what is called a mixed number. Because this is a whole number part, right? And this is a fraction because it's not a complete thing, right? If we're gonna, I don't want to make this about dollars and cents, but if you put this like $2.65, you recognize there's two whole dollars and then you have a fraction of your next dollar, right? We're talking about dollars when we're talking about commerce, right? So we get that fractional part, but we could literally be talking about anything, okay? So the question the other day was, well, how do I go from here? And actually, this can be reduced. That's why I picked 65. This is actually quite easy. So as I said in a different video, there's implicit things going on in numbers, operations going on in numbers. Okay, I'm going to get this close to me. Hopefully, again, I'm sorry. I hope the glare's not too bad. Look at the reflection. It's like one of those loops forever. Can you see it? Is it too bad? I know you see picture in picture. I really need to just get a new system with the notability, which I haven't done yet. This is 200. Okay? Because the fractional part is now in the hundreds. This is an implicit division, which we don't need to get to here. But implicit in a mixed number is addition. So you can say this is like 200 over 100 plus 65 over 100. Okay? And now we can add those. That's 265 over 100. This is a decimal. This is a mixed number. This is an improper fraction. Improper simply means that there's a bigger number in the numerator than the denominator. Okay, there's a greater number in the numerator than the denominator. What that means is you have a fraction whose value is greater than 1. And we know it is because it started here, right? It's 2.65. But that's what improper means. A proper fraction means you've reduced it either into a mixed number or a decimal. If you're being improper in the world of politeness or manners or courtesy, right? That might have negative connotations. The prefix "im" simply means the opposite, the inverse of whatever you are doing. So if a proper fraction looks like this, an improper one looks like that. That's it. That's it. Okay? Maybe I'll do a different video on that. But now you can reduce this. And this is where prime factors come into play. I talked about that a couple videos ago. And I can do more if you have questions. But so we can find the prime factorization of these. But if you know that you have factor rules, okay, 265, 100, anything that ends in a 0 or a 5 can be, is a multiple of 5, okay? So that means you can divide both of these by 5. Well, 100 divided by 5 is 20. Hopefully you know that there are 20 nickels in a dollar. 65 divided by 5, well, we already know this is going to be 40. But it's the 65 that we care about. 65 divided by 5 is actually 13. So we get 43. This part is 43, and 13 would be 53. You can check my math on the calculator with you. These two numbers are called relatively prime. Relatively prime, which means that they might be prime numbers, might not be prime numbers. 53 actually is. But they are prime compared to each other. Okay, so this is an example. It's just a single example. So decimal form, mixed number. The plus isn't there when we write it, right? We write it, but it's implicit. That's how this becomes this, because implicit in a mixed number is a plus. Math is a language. There are so many implicit things. You know how kids do shorthand in texts? And yes, I'd say kids because they're the ones who weren't, we don't have this. I mean, most adults hopefully don't use that much of shorthand because they understand the implicit rules of what the word is, right? Using all lowercase or no period or apostrophes, right? Implicit in mathematical communication is that this is a addition. That's how you get this. And now this is an improper fraction. And this is the improper fraction in reduced form. You keep reducing it until the two numbers are relatively prime. I'm going to leave you with the question, what is a prime number? Hope you remember. If you don't, we'll talk about that another time. Have a lovely evening. Miss Thompson is out.